Okay, everyone, welcome to AP Computer Science A by Daniel Kim. So let me introduce a little bit of this course before we get into the main stuff, okay? So this applies to the 2025-2026 academic year and beyond, as the exam is undergoing major change this year, okay? All right, so why Daniel? Why take this course from me? Okay, so let me do a little bit of an introduction of myself. So I have a PhD from Seoul National University in engineering with a lot of field experience, meaning a lot of researches, and in that process, I've learned how to code a lot. Okay, so I mean it's been quite a while since I've started coding, but you know this was when I really delved into it. Okay, so I'm currently the main computer science, math, and science instructor at one of the biggest institutions in Apgujeong. And, you know, I have a perfect analysis of the past 15 plus years of exam. Well, the exam 15 years ago, obviously, is not exactly the same as the exam is right now, but I've really done my research and I've really delved into the question types. So over the past years, I can literally name all of the questions types that appeared on the exam. So I've done a lot of research on my end, and so I basically know what I'm talking about, okay? So I've looked at all the College Board, prep books. So this curriculum, this course was designed to cover the absolute essentials that you need to get a 5 on the exam. Okay, so just follow me. And yeah, and obviously I've also been in your shoes. I've studied in California until high school, and yeah, I've taken this exam when I was in junior year. So I've been in your shoes, so I know what it feels like. I mean, I was also confused a lot back then when I was first learning it, so I know what all of you are going through, and now I know what you need, okay? So, yeah, rather than me just explaining, let me show you some statistics here. So according to the College Board score distribution, the 5 ratio for the exam was usually about 24 to 25% in the recent years. So, well, if you look at my performance for my students in the 2025 exam, so 4 to 5 ratio was about 100%, and the 5 ratio was 70% out of the total. So, which is about a little less than triple the official count. So, yeah, but obviously this is from the data that I've collected. Yeah. So, but anyways, as you can see, I've been doing pretty well over the past years. Okay. And also, I also have developed, since, well, I'm a computer science teacher, so I should show you what I can do. So I have many apps and websites. Well, at this moment, some of them are due to be launched soon. By the time you're watching this, it might have been launched. So I'll leave those in the descriptions. And yeah, so here, like, I've developed some IDEs myself in the Jupyter Notebook style for Python, for example. Like, they don't have that kind of platform for Java, so I've created one myself, and I'm using them throughout my classes. Well, for this course, right now, when I'm filming this, it's not complete yet. I'm beta testing with some of my students right now, but by the time you watch this, it will be officially launched, okay? And I also have like these websites where you can do like quick daily quizzes every day, like short coding questions where you can kind of use it as a brain refresher. So yeah, a lot of these, the informations will be available through my other channels and my contacts. So I'll keep you guys updated, okay? All right, so let's talk a little bit about computer science though. Like what is computer science and why computer science? All right, so computer science is about studying how to create, arrange, and manipulate data to solve a problem, a task, or satisfy users' needs. So everything that we do on the computer is going to be about data. Okay, so like even when we're playing games, moving a character using the WASD keys, the character is moving on our screen, but in the background, what's actually happening is we are changing the character's coordinate data. Okay, so everything will be about data. Okay, so it's very important. All right, and programming is about writing code to tell the computer to access, manipulate, and present these data and change the data into the appropriate formats. Okay. So why study computer science? Well, there was a computer science boom during the COVID, but the hype isn't really big right now. The thing is, well, now it's become like an essential field of study for a lot of the other fields. For example, like in biology, you need to know computer science for simulation, right? You need to code the simulation yourself. In history, you need to know computer science to process data and analyze historical patterns, for example. Like in business and finance, you need to code statistical models to analyze data. So computer science is not just about creating apps, like creating programs, creating games, creating websites, but it's involved in so many other things. Basically, everything that we can do on a computer involves computer science. And what you learn in this curriculum is going to be the fundamentals of that. All right, so computer science now, especially like when you go to college, there will be a time when you need it at least once, okay? Even if it's not computer science or engineering. Okay, so computer science is a must-needed skill in the real world, and another reason for that is because of the recent AI boom, right? So without knowledge in computer science, you're going to fall behind in your career. What I mean is, yeah, you can use ChatGPT or Claude or Gemini, just ask questions, but in order to maximize the use of these AIs, you need to know a little bit about computer science. For example, like, it's very easy to create websites and platforms these days, but without the knowledge of, a little bit of the knowledge of computer science, even if the AI can help you, it has an extent, okay? You need to provide the ideas, the structures, the framework, like the inputs and outputs, what it's going to be like. So all of these comes from you. Okay, the AI is just going to be a tool, so you need the knowledge in computer science in order to create those. And, analyzing data. Yeah, the AI can do it for you, but how are you going to give it the data? How are you going to organize it? How are you going to interpret the results to your context? Okay, so computer science is a mandatory skill in the time that we're living in. Okay, and as the AIs get more sophisticated, the ones with the more knowledge in computer science is going to excel even faster. Okay. All right, and this AP-CSA course, the curriculum is in Java. Well, the AP-CSP, students are given the freedom to choose a language, but with AP-CSA, it's specifically chosen as Java. And why not Python? Like Python, it's like English, okay? Most people speak Python. But here, Java is about 15.52% according to the recent statistics. But why not Python? Well, the reason is kind of simple, okay? And it's kind of ironic. Well, Python is like English. It's the most used programming language. It's easy to learn. It's easy to use, with a lot of grammatical freedom on the programmer's end. So, but that's actually the reason why AP-CSA is in Java, okay, and not in Python. So starting computer science with Python actually prevents you from learning the details of computer science. With Python, you can skip a lot of things while you're coding, okay? But with Java, it's very strict about mentioning the data types. And so if you look at this, ironically, Java has stricter grammar rules, but that's exactly why it's easier for beginners to learn computer science. It's because of what's called the static type in Java. Everything in Java, you must have a data type, okay? Defined data type. And this whole process, that's just one part of it. There's a lot of more reasons. It gives a strong base knowledge. So it's like not learning what nouns and verbs are in English, in a language. The Python is. So like Java, you actually learn the grammatical structures and the rules. And it's also like, you don't know what rational numbers, whole numbers, and integers are in math. Okay, so that's why APCSA is in Java, and it's because Java allows the beginners to understand what actually goes on in the background as we run our codes. And then last thing, let's talk about the test a little bit. So like I mentioned, there are major changes to the exam starting in the 25-26 academic school year. So, this is a previous exam and new exam. As you can see, units, there were 10 units, and it's been condensed. They didn't get rid of 6 units, okay? The 10 units, they took out 1 unit, and then they condensed the rest into 4 units. So this unit on inheritance has been taken out from the exam, which was the most difficult unit in APCSA. So lucky for you guys, that's no longer on the exam anymore. But we do have some additional topics like reading files and data sets. And we also have 2 additional questions on the MCQ. And that also changes the weight of the MCQ because MCQ weight has been increased from 50 to 55%. The FRQ, the number of questions is the same, but the College Board does outline that the length of the question is going to get shorter, and accordingly, the number of points and the weight of the FRQ is going to decrease, and which is also a good thing for you guys because usually FRQ is where a lot of students have a hard time with. So there's a slightly less pressure, but I mean, it's still worth 45%, so it does account for a big portion of your score. All right, so they also took out a topic from the FRQ. That topic is still in the exam, but it's just not covered in the FRQ. So these are the 4 units. So using objects and methods, selection and iteration, class creation, and data collection. So this will be the distribution of those topics. Okay, so, well, actually, the Unit 4 used to be about 50% of the exam, so the weight of that kind of decreased. So, well, we're going to take a look at all of these topics, all right? Okay, so finally, before getting started, let me just tell you one thing, okay? All right, so computer science, like I said, it's a language, okay? I mean, it's called a language. Java is a language. And the reason is we are going to communicate with our computers, okay? So, and then we need to express mathematical and logical concepts to tell our computer to do something. So, if you can speak more than one language, if you're watching this, you can probably speak, Korean and English and some other languages. But think about it. What did you do first when you're learning a language? Well, if you kind of learned it like me when you were very little, then you might not have specifically studied like vocabs and grammar. But like in high school, I studied like Spanish, and we had to learn the grammar. We had to memorize the vocabs and everything, right? So in computer science, it's exactly the same thing. A lot of people think, hey, computer science, you don't need to memorize anything. You don't need to study for anything. It's very easy. It's not, okay? That's for a very select few. But usually, students have a hard time because they don't memorize a lot of the things that I tell them to memorize, okay? So think about it. Like, without knowing grammar and vocab, can you speak a language fluently? Maybe without grammar you can, but like without vocab, can you express yourself at all? You can't. And moreover, can you score like a perfect score on like TOEFL test or SAT? You can't, okay? So there are actually a lot of things that you, as beginners, that you have to memorize and study in the beginning especially, okay? So don't think that, it's going to come to you naturally, okay? And I will point out some of the things that you must memorize and you must watch out for. So those things you have to memorize like you're memorizing vocabs for a new language, okay? All right, so all videos are divided into the College Board topic outline. So starting with 1.1 and then going on. So each topic will be about 20 to 40 minutes. Sometimes it's a little shorter than 20 minutes, but usually it's within that range. And per unit, so 1, 2, 3, 4, there will be about 2 to 3 stops in the middle where I'll give you guys syntax questions and coding exercises. So we're not going to actually get into the actual exam type questions in the middle, because as beginners, well, this is kind of designed for the beginners. You need to first learn how to write short sentences, okay? So rather than answering, going straight into reading comprehension, I've designed this course so that you first learn how to write these yourselves, and then in the next following curriculums or courses, I will get into the actual exam questions. Okay, so yeah, there's a very specific reason why I designed the questions that way and the exercises. So please follow along. And yeah, like if you can't answer these questions, there's no way that you can answer the actual exam questions. So we're going to take step by step. So we're going to start with actual syntax questions and coding exercises. And yes, in the first coding exercise, I do explain a lot of, I do explain the specific steps and the platform that we're going to be coding on. So please wait for that. All right. So our goal for this lecture series is to learn the fundamentals and grammar. Okay. So, well, as you've seen, I've introduced a lot about myself, but as you can see, I've kind of have this proven data that if you stick with me, then you can get a 5. Okay, so yes, you do need to try a little bit on your end, and I will make sure to guide you until our exam in May to get you a 5. Okay, so if you stick with me, I will guarantee you a 5, but with, parentheses, a little bit of effort on your end. Okay, all right, so let's go for it. Okay, so AP CSA by Daniel Kim. Please follow me. Okay, so let's get into our lectures, and I'll see you guys in the next video, our first lecture. Okay, bye-bye. Okay guys, so we learned what variables are, and we learned how to declare, initialize these variables so that we can use them. Okay, so now let's take a look at how we can use them, and that will be our next topic, expressions and output. Okay, so everything that we're going to be doing for this course, so the algorithms that we're going to be writing down, so everything is going to be text-based. Okay, we're not going to be working with graphics. We're not going to be, coding and drawing like dragons and, like, I don't know. But, so everything is going to be text-based. That means the outputs, all of our outputs is going to be text-based. And we need to, that means we need to know how to, we need to know about the code statements that will display these outputs onto our screen, our result screen called the console on our IDE. Okay, and there are 2 statements to display our output in Java. Okay, of the coding languages that I can write, Java has the most inefficient way of printing these. Okay, I mean, if you go to Python, it's just going to be print, right? But here we need to write word by word, system.out.print, and then whatever we want to print, that will go into the parentheses. Okay, so again, and the other one is system.out.println, and then expression. Okay, so let's see how that works. So this, like, if you go on like any kind of IDE or like basic coding classes, like printing hello world is like the first thing that you'll see, but it's a text type which we're going to cover later on. So we're just going to take a look at this and then move on. So on your IDEs, like I explained, this is where you write your code, and this is where the result will be displayed. So whatever we put into the parentheses for the print statement, that will be printed on the console right here. Okay, and then this screen is from the platform CodeHS that we're going to be using. Okay, all right. So what's the difference between print and println? Let's take a look. So system.out_print expression. This prints the value to the console. Okay, the cursor remains on the same line. So the cursor is like when you work on Google Docs, for example. You know that blinking vertical line, and then like if you type it in, you know the word types from there, right? So it's talking about that, the cursor. What that means is once we print something like hello, ignore how we ignore the data type here, the strings. We're going to be taking a look at it in the later topics of this unit. But anyways, hello. After printing it, it means the cursor is not going to go to the next line. It's going to stay on the same line. And whatever we print next will get printed on the same line. So if we print hello, print world, what will happen is it will print hello world to the console. So after printing hello, Java does not move to the next line. Okay? So guess what println is going to be for? So println expression. It prints the value to the console, and then it moves the cursor to the next line. So that means whatever we print afterwards, it will be printed on the next line. So think of it as printing the expression here and then pressing on an enter key. Okay? So system.out.println hello, system.out.println world. Notice that hello is printed and world is printed afterwards. And think about, okay, so if we have like print after this, I don't know, some kind of a phrase there, what's going to happen next? So it's print, but because we used println here, what gets printed is going to be on the next line. Because after printing world, Java moves that cursor to the next line. So that's the difference. And a lot of the times, mostly we use println when we, well, as far as our exam is concerned, we'll mostly be using println. But yeah, the MCQ part actually has plenty of questions involving print. So you do need to know how to use both of them. Okay. All right. So if you print, yeah. Okay. Sorry. So and notice that here it says expression. Okay. So whenever it says, you know, we can put in an expression as arguments into our code statements, this means that you can put in, you know, literal values, meaning like just literally numbers, actual numbers, instead of variables. So like 5, 10, 11. And then you can put in literal values, you can put in variables, and it will print the number or whatever value is saved in that variable. And you can also print expressions of variables and values. Okay, so here, this is what I mean by a literal value. It's an actual number value. So the output here will be 5 into score equals 100. We can put in a variable into that print statement. It will print the value saved in that variable. So, but what if you're like, oh, but what if we want to actually print the words score, like actual text score? That's for later part of this unit. But just heads up, we can just put in double quotation marks, and that will change that score to a text value. All right, so before we talk about how we can print actual expressions involving operations, we need to know about how to do the operations, right? So these are basic math operators in Java. Okay, so a lot of these, if you've worked with like spreadsheets or Excel, you would know the symbols here. I mean, addition, subtraction is the same thing, but on the computer, you know, a lot of the times the symbol that we use to do multiplication and division are the asterisk and the slash. Okay, so multiplication, division. Okay, I mean that's I think that's a common, I think it's safe to say that's a common knowledge. But anyways, that's multiplication and division. This, if you haven't studied computer science before, it's probably the first time you see this. It's called a modulus operator. The symbol, it's different in some languages, but the way it works, what it does is the same. So it's a modulus operator, and another name for it is remainder division. Okay, so simply put, so division gives you a quotient, right? But this modulus, it gives you the remainder of the division, not the quotient. Okay, and why do we have that operator? We can actually do a lot of things because of the modulus operator, and we're going to take a look at a few of these algorithms in a bit. All right, so how do we do it? It's the same thing. It's like using a calculator. Okay, so int sum. So we have int x equals 10, int y equals 3, and then we have int sum equals x plus y. So the sum will have the value that's the result of this addition. So sum will contain 10 plus 3, so 13. Same thing here, product x times y. So if you print out all of the values here, it'll be 10, 3, 13, and 30. Now, a division in computer science, again, in any language you go, not just Java, has some complicated stuff. I mean, Python, well, let's just stick to Java, sorry. So let's take a look at division here. So int quotient equals 5 over 2. If you think about it, wait, why is that int? Isn't 5 divided by 2 2.5? Okay, but actually, the result of 5 divided by 2 is 2, not 2.5. And what? Well, let's take a look. So when you divide an int, so an int type divided by an int type, it's always, the result is always an int. And we said an int type only has integer, can only save integer numbers, right? Not decimal numbers. So the decimal part of the quotient gets truncated off, meaning gets cut off. So it doesn't get rounded. It's not rounded, okay? It's very important. It's not rounded. It just gets cut off. So although the result is going to be 2.5, this 0.5 just gets truncated off, okay? So the output here is going to be 2, not 2.5, okay? But if you divide two double type values, 5.0 and 2.0, the result will be 2.5, okay? So if you divide double and double, that correctly does it. Okay, so one more thing that we need to cover, and then we'll get to some practice exercise. And the next is called compound assignment operator. So we learned the mathematical operators, and we learned assignment operator. Now, let's take a look how we can combine them for a shortcut, to use them as shortcuts. Okay, so there's one key principle in computer science. It's called the dry principle. So don't repeat yourself, okay? So a lot of people say that programmers are lazy, so they try to do things as short as possible, but it's actually not the case. Well, maybe, but the main reason is because we need to be as efficient as possible. We need to minimize the number of lines of code that we're writing. We need to shorten the amount of code that we're writing because, again, every single line of code is going to accumulate to the size of your program. So in real life, when you're creating a program, you need to be as efficient as possible because, you know, if you start repeating yourself by the end, like even if you thought, okay, well, I guess I'll just repeat myself here. But if that continues to accumulate until the end, the size of your program will get substantially larger. So again, this dry principle is not because we are lazy. It's because we want to be as efficient as possible. So let's say we have a variable called score. Okay, bringing back from the beginning. So let's say we have 90 assigned to it. And let's say we want to update the score by 10. So if we want to update the score, we do score equals score plus 10. Okay, so one of the things that I should point out here, that assignment operator, the order of precedence for the assignment operator is last. It's because we need to do everything on the right-hand side first and then assign the resulting value to the variable. So here, this score, we're going to be dealing with the initial value saved in score, right? So which is 90. So it'll be 90 plus 10 equals score, okay? So what's the issue here? It's that we are repeating ourselves. So although this is a simple example, it's always better to avoid repeating ourselves in a single statement. Okay, so we have compound operators that will allow us to avoid that. So Java has shortcut operators that will allow us to avoid repeating ourselves. So as you can see, the plus equal sign here, okay? So A plus equals B, that is going to be equivalent to saying A equals A plus B, okay? And A minus equals B, that will be equivalent to saying A equals A minus B. A times equals B, same thing, so on. So even until the modulus, okay, the modulus will be A equals A modulus B. Okay, so we use these shorthand or shortcut operators when we want to update the values saved in our variables. And yeah, so not when we're like just reassigning a completely new variable, but again, when we want to update the values of our variables. Okay, so we can have something like this. Int score equals 100. So score plus equals 110. That will be plus equals 10, so it'll be 110. If we subtract 20, 90, and then if this will update our score by multiplying it by 2, so this will become 180. Okay, so our final output here will be 180. So just remember, like in the beginning, as a beginner, it does get a little bit confusing whether the equal sign comes first or the mathematical operator comes first. Just know that just remember it this way, the equal sign comes last, so if we read from left to right, that equal sign needs to come second so that we can multiply first and assign it after. Okay. All right, now there's even a shorter operator. So we have a simpler shortcut when we want to increment or decrement a variable just by 1. Okay, so if we want to increase the value by 1 or decrease the value by 1, okay, we use this increment and decrement operators. So this increment operator will add 1 to a variable. This decrement will subtract 1 from a variable. So this, just by having this line, this shorthand operator does not require equal sign. Okay, so just plus plus will be enough to update the value of the variable. So x plus plus is equivalent to saying x equals x plus 1 or x plus equals 1. And x minus minus, that's equivalent to x equals x minus 1 or x minus equals 1. So again, just having that line by itself, we don't need an equal sign. That will update our value by 1. Okay, so yeah, so int x equals 5, just having that one single line, x plus plus, that updates the value to 6. So y will be 6 after this, okay? All right, and that's it for the shorthand operators. And now let's go to some of the syntax questions, and then we'll also try our very first coding exercise after this, okay? Okay, so the if statements that we've looked at so far, the code statements ran based on a single condition, right? So if this is true, then do this. Else, do this, okay? But yeah, so if you think about real life situations, sometimes we make a decision based on multiple conditions, meaning only when, you know, for example, 2 conditions are true, we're going to do this, okay? So we're going to take a look at those cases, and these are called compound Boolean expressions, okay? So nested if statements was a little bit like that, right? Because we had if this is true and if this is true, we run this, okay? So we're going to look at a little bit of a simpler way of writing that code using additional operators. Okay, so These are called logical operators. We've already seen the logical not. Okay, logical operators allow us to combine multiple Boolean expressions into a single compound expression that evaluates to true or false. So the three main logical operators in Java are these. There are more logical operators, but again, as far as our curriculum is concerned, we only need to know these three. Okay, so the not, we already saw it with the not equal to, and just by itself, it's also an operator. And we have the double and sign, and then we have the or symbol with the two vertical lines. And if you're not familiar with computers, a lot of the time students have a hard time of finding where that symbol is on the keyboard. It's the key above the enter sign. So that key has the backslash. Remember, with the new line, we had the backslash n. So that key is used for that as well. And then if you click on shift, that button, it gives you this vertical line here. Okay, so let's take a look at the logical not first. The not operator inverts the value of a Boolean expression. So a lot of the times we use it to flip around a value. So an easier way of thinking about this is making a connection to the negative sign in math. Okay, so Boolean is raining equals false. Okay, so that's the assignment. So that's the initial value of is raining. But if you check this condition here, check if it is not raining. If not is raining. So without the not symbol, how did we interpret that if condition? We said if is raining is equal to true. Okay, but now if we attach that not operator in front of that variable, now we're checking if is raining is false. So now we interpret this as if is raining is not equal to true. So meaning if is raining is equal to false. Okay, so if is raining is false, then we run this statement. Okay, if it's true, then we go to the else statement. Okay, system.out.println, bring an umbrella. Okay, so yeah, as you see here, that flips around the value that we're checking for. So that flips around the condition, and that also we'll see later on that it flips around the. We can use it to flip around the value of a Boolean variable. All right, and here's something called the truth table. Now we're going to have slightly more complex Boolean expressions, and yeah, it would be great if you can evaluate the Boolean expression in your head, or just like writing down simple evaluations. But if you can't, the truth table is something that you can use. So in the truth table, we write down the possible values that our variables can take on, and we evaluate the results, all the possible outcomes. So when evaluating Boolean expressions, you can use what's called a truth table to lay out all the possible outcomes. So for A, if we have a Boolean variable A, its possible values are true and false, right? So we list that in the first column, and we look, and then if this is the actual value, the expression that we want to evaluate, we evaluate what that's going to be, like when A is true or when A is false. So when A is true, not A is going to evaluate to false, right? And when A is false, not A is going to evaluate to true, okay? All right, so let's go to the next logical and. So that's an and operator, meaning, if you've, spent some time doing logics, studying logics, that and means like the entire expression will only evaluate to true if both conditions are true, right? So let's take a look. So we have two variables here, int age and has license. So age is an integer and has license is a Boolean variable. Now, for this first for this print statement to run, that means both of these conditions has to evaluate to true, okay? So again, when two conditions are bound by an AND operator, that means for the entire expression to become true, both of the expressions have to evaluate to true. If one is false, the entire expression becomes false, okay? So here, only if the age is, let's evaluate this. So age is 25, so the first condition is true. The second condition has license. So again, we interpret that as if has license is equal to true, right? So it is true, so both of the expressions are true. That means this entire expression is true. So it's going to print you're eligible to rent a car. But if one of them was false, then we automatically go to the else statement. So in this case, if we have two conditions, or in this case, well, variables, but we can also, if it's a longer expression, we can write the expressions here as well. But anyways, since we're working with two variables here, okay, we list out all the possible outcomes, okay? So when A is true and B is true, when A is true but B is false, when A is false but B is true, and when both of them are false. So if they're bound by an AND statement, what would the result of this expression be? So if both are true, then it evaluates to true. But like we said, if at least one of them is false, then the entire expression becomes false. So for all the other three cases, they evaluate to false, okay? So when you have an AND statement, AND condition, so the only time when it will evaluate to true is when both of the conditions are true. So that's consistent with what we've said just before, right? Now, another thing about this AND statement here is a nested if statement can often be written as a single if statement with the AND operator. Because if you think about it, this nested statement, what do they say about this statement here? When does it run? Only when both of these if conditions are true, right? And that's exactly what we just said with the AND statements, right? So we can rewrite that as this, okay? So if age is greater than or equal to 25 and has license, we can print this, okay? So the version with the AND is more concise and often easier to read. But here's the thing though. It's easier if the cases only involve these two conditions, but if there are other cases involved where we need to write else and else if statement, sometimes the nested way is a little bit more convenient to write. Because here we need to think about what our else if statement and what our else will be, okay? But with the nested, although it's going to be longer, okay, it has a more clear organization if there are more conditions. Okay, now let's move on to the OR statement. Okay, so the OR operator evaluates to true if at least one of its operands is true. So we have two Boolean variables here. So we have if has coupon or is holiday sale. So again, going back to logic. Hello everyone, welcome to Unit 3. Okay, so in Unit 1 and 2, we learned all the basic grammar, okay, syntax that is required for us to get into more complex stuff, okay? So like I've been saying in the previous videos that, we're going to learn how to create our own class. Now we're going to start creating our own class, okay? So let's first start with abstraction and program design. So we need to first look at, although we talked about it a little bit, okay, it was just tip of an iceberg, okay? So we need to actually get into what a class is made of and what is required and how we write it, okay? So we're going to first look at the design of it. So we need to first look at the word abstraction. We've talked about it before. So abstraction basically means simplification. It means we don't really necessarily have to know what's going on behind the scenes for us to use it. Like system.out.println. Okay? Although that will come in Appendix 1. Abstraction, so far, a lot of the times, a lot of the classes and methods that we looked at with strings, scanner, we actually didn't know how these tasks are done. Okay, we just used it. Okay, so abstraction means hide complex details, show simple interface. So simple view means the complex details are hidden behind the scenes. And that's what we're basically going to do now. We need to define the complex details behind the scenes. So let's think of, TV remote control, or even this clicker, or, well, not a lot of you probably use TV remote controls these days, but you guys still know what it is. So what you see would be the buttons, the volume buttons, the channel buttons, and if you're using an IPTV, then you'll see a lot of buttons for like other services like Netflix. And what's hidden behind the scenes? So electronic circuits, signal encoding, infrared transmission, frequency modulation, all of these we don't need to worry about in order to use the remote control, right? So this is a concept of abstraction. So like using a microwave, so simply put, we put the food in, we set the time, we press the start, okay? But what's hidden behind the scenes is, the magnetron waves, the radiation patterns, safety sensors, power regulations. So you don't need to know how the microwave works for us to use it, okay? We just need to know how to use the simple buttons and the functions. So we hide complexity behind simple names like print, although it was system.out.print, .length, .random. So we just need to know what goes in and what comes out, right? So simple names for complex operations. So what we have been so far is like a user, okay? We used the print, we used the length, we used random. We didn't know how they work behind the scenes. Now we are going to become the actual creators, okay? So we're going to write our own methods, we're going to create our own classes, we're going to build abstractions, and we're going to build our own objects and our classes, okay? So we've been a user, so we used it, we didn't design it, we didn't write it, we didn't code it. Now we're going to become the creators. All right, so these are basically the steps that we're going to be taking, and we're trying to understand the concept. All right, so now let's take a look at what an object exactly is. I mean, when we made scanner and when we made string objects, we kind of looked at it, but those are not the only object types. So if you think about it, well, we probably won't be able to think about it right now, but anything in real life can be created into an object, okay? Anything, okay? So an object has characteristics and it can perform some kind of actions, okay? So if we create a dog object, okay? So a dog object has a name, breed, color, age, well, and a lot of other characteristics, right? But these are a few of them. And what it can do is, bark, walk, eat, sleep. So these will be the actions or behaviors, okay? So the object that we're talking about is the object itself. So dog is, we can represent that with the dog object. And characteristics, well, they become what's called attributes. Actions, these become methods. And category becomes class. So a class is like a blueprint for an object, okay? So let's think of a car, for example. Like it's got, what kind of characteristics does it have? So a color, brand, year, miles. So each car will have these attributes, but not all cars have the same characteristics, right? For example, my car is gray, okay? The brand is Kia. The year is, I think it's 2023 or something, okay? And the miles, obviously, well, I'm not really sure about my car. I haven't really checked recently. I haven't paid attention to it, but yeah, somewhere, around there, okay? So So a car, all cars might have these characteristics, but the actual values, they're going to depend on each individual cars, okay? That's a very important concept that you need to understand. So we're going to have, a blueprint for creating cars. So we can create multiple cars out of that blueprint, okay? So for each object, they're all going to have these attributes, okay? They have the attributes, but the actual values will be different for each car, okay? Very important, okay? So, same attributes, different values. So if we have multiple students, let's create them into objects. So student 1, okay? The name, Alice, grade 10, so sophomore, GPA 3.8. Student 2, Bob, 11, 3.5. So these are all student objects, okay, but they all have the same characteristics, but the actual values of those characteristics are different, okay? So all have same attributes, but different values, okay? Now let's talk about the behaviors. Oh, by the way, like all of these that we're talking about, the characteristics, attributes, each will have their dedicated topics in the upcoming videos, okay? So here it's just another intro video. All right, so what an object does. Methods equals actions equals behaviors. So it can, so anything that an object can do, an action or a behavior, okay, we can represent that with methods as well. So for example, what can a phone do? Make a call, send text, take photo, play music. Although it's going to be a lot more sophisticated in real life, like how your phone's operating system is coded, but general, like in a more easier terms, yeah, they will have some kind of these features on our phones. Okay, so yeah, so methods tell objects what to do. So planning before coding, it's an important process. A lot of the times, students think, okay, so this is what I'm supposed to do, let's start coding. And then they get stuck, they get frustrated, and they quit, okay? So I've seen that more often than you would expect. And here's the reason why, okay? Not even real developers or programmers actually get straight into coding. They need a brainstorming process, they need a planning process in order to write out the actual code and algorithms, okay? So it has to be the same for you, okay? When you read something, like read instructions to do something, I mean, if it's easy, yeah, you probably can just get straight into the coding, but you still need to kind of stop and think about how you're going to write it. So in real life, don't worry about the code. Before you, get into it, think about the steps, okay, in just, in English, okay? Like, what do you need to do? So if I need to create a dog object, what kind of attributes can it have? Like, what will my dog do? Okay, so you need to do that. Describe in words, and then draw pictures, meaning draw diagrams like the flow charts. Identify the parts. So you need to go through all of these steps. I mean, there are more like these models for creating algorithms and with more steps. But as far as our algorithms are concerned, you need to at least take these 3 steps. You need to literally write down, brainstorm your ideas somewhere. Okay, I mean, this is for those who have been getting stuck on those coding exercises. And trust me, you might not. Okay, everyone. So we looked at how to become responsible programmers. Now, let's get into the actual data collections part. So, the next topic is the introduction to using data sets. And here we'll give a general idea of what is going to happen when we deal with the data sets. Okay? So, a data set is a collection of specific pieces of information. And data sets can be manipulated and analyzed, and processing data follows patterns and algorithms, and some patterns work across different data structures. And the last part is pretty important because we're going to be taking a look at a few data collection types, and 2, and then the 2D arrays that we're going to take a look at is basically the arrays that we're going to learn in the next topic. So But between array and array list, the grammar is different. I mean, the methods can be different, but the logics is going to be the same, all right? All right, so what is a data set? So we said it's a collection of specific pieces of information. So in real life context, it will be like a list of students in class. So when we are, for example, when we're creating like an attendance tracker program, then like we would be using lists inside. And letters in a word, string. So we will actually take a look at that today, not today, in this topic. And strings are technically data structures as well. And scores for multiple games, items in a shopping cart. So when we need to keep a track of multiple values of the same category, same item, then that's when we would use data structures, okay? Here it's a bit important that we differentiate why we encapsulated these different variables into an object versus why we're using data structures here. Encapsulation involved, having multiple variables, okay, that are related to a certain topic, and then we kind of put them together in a capsule. When we're dealing with data structures like data collection, we're basically keeping a track of the same item values, okay, multiple values of the same item in one list. Okay, so there's a difference. Okay. All right, so what is a data set? So without data sets, if we have multiple students and we need to keep a track of them, creating one variable for each of these students is going to be highly inefficient, and it's going to make your code look very messy. So we do not, that's not an ideal thing to do. So instead, we use a data collection, a data set, and just put them in the list, and then we can refer to them by their position numbers, called index numbers, okay? So in real-world applications, so social media, lists of friends, posts, banking, transaction history, games, high scores, inventory, school, grades, attendance, and so on. So think of it this way, anything you can kind of represent with a spreadsheet, that's what these data collections will be for, okay? So we have actually dealt with a type of a data collection before, and it's strings, okay? So strings, we said it's text values, but I think I did briefly mention that strings are actually, a list of, individual characters. And that is why we were able to use index numbers on the strings in order to retrieve or access the individual letters in a string. And that is because in the memory space, okay, a string is saved as a series of blocks where each block represents a character in that string. And we refer to that each individual character using their position numbers in this series of spaces. So hello, so 0, index 0. So we retrieved it using the substring method. Substring 0, 1 would retrieve the first letter. So that's why the index numbers exist. So if you have a data collection, so if you have a list of, characters in this case, we can refer to them each by their position in the series of spaces in the memory, okay? So again, a string is a collection of characters. So here. So it has these properties, right? We can refer to the size of it with length, which is a method that returns how many characters there are. Okay? And we can access individual items using the substring method. For example, again, 0, 1. That would access the H, which is the first letter in the string. And then we can process the string with a loop, right? Remember we said we can traverse over the loop using a for loop, and sometimes we can do that with a while loop as well. And then we can look at individual letters using the index numbers, okay? And the index starts at 0. We said that's called zero-based indexing. And the last index is always going to be length minus 1. It's because the index starts at 0. So if there's 5 characters in a string, because we start the index number at 0, the last index number will always be length minus 1, which is 4. So in this case, it will be 0, 1, 2, 3, 4. So the length of the string hello is 5, and then you should notice that the last index is going to be 4. All right, so here's just an example. So string message Java. And here we have a loop that processes this string. We're going to start at the beginning, I equals 0, and the I is less than message dot length. We said that's one of the most often used condition, right? So starting from the front until the end. So the I will act as an index number here, and then it will go up to I. Length minus 1, okay? And then I plus plus. And then here we have string letter equals message dot substring I plus 1, right? And we said using I plus 1 until the last index will be okay. But later on we'll see that with arrays we can't do it. It's just something special with the substring method, because if we designate the I plus 1 as the end index, then technically the index that we're trying to access is going to be that minus 1. So I plus 1 minus 1. So that will not throw an index out of bounds exception. And that's actually how we need to access the last element. All right, and then this will just print the message. So here's the visual representation of that. So when I is 0, it will look at the first letter using substring 0, 1. And then when I is 1, it'll be 1, 2, which will be the second letter, 3, 2, 3, V, and then 3, 4, and then it will look at the last letter. Okay? All right, so here's some of the common algorithms that we can perform with data sets. So in the later topics, we're going to be looking at how we can do these. And some of these we've already seen, and some of these we can do that already with the string methods. But with arrays, there will be we'll be able to do that a little bit differently. And with array list, yes, a little bit differently. So access, we get specific in the elements. So with strings, we can do that with the substring. Search, we can search for a specific letter or character in a string using the index of. And we can also count how many of something is in the string. And then we can count, so we can traverse over a string, for example, and then create a count variable, and then increment the count whenever we run into the occurrence of that specific letter. And transform, change elements. Well, we did that kind of with the uppercase, but what also counts is like concatenation, for example. And then like we can take substrings and then just add another substring to it. So those things will be transformations. And filtering, selecting certain elements, getting only the letters. So if a string contains letters and numbers, like we can traverse over the string and only get the characters. So these are some of the examples of how we can, so the examples of algorithms like accessing, we use a substring method to obtain the letter D, for example, and then we can use index of L to search for L, okay? And then here is where the first L is. And then for count, if we want to count vowels, remember we did those kind of comparisons before. So we would increment the count variable whenever we run into a vowel. So in this case, it would be 2 at the end. Transform, like we said, that's not part of the official curriculum, but it's one of the helpful methods that will help if we know what it is. And the filter, like we would traverse over it. Remember, how would you change this to ABC? Like we said, one of the things we can. Okay, everyone. Just like with arrays, we do need to look at some array list algorithms. But you also need to understand that with what we did with arrays, we can technically do everything with array list as well. It's just a matter of what kind of methods are we using. But the logic between the arrays and array lists are going to be exactly the same thing. Also, there's going to be searching and sorting algorithms that will come later on in the unit. Yeah, so we're going to set that aside. We're going to look at the rest, okay? So here, so these are some standard array list algorithms. It does have very common similar ones with our array algorithms. So let's start with the first one, finding minimum. Okay, so finding minimum. Okay, why did we say we start with the dot get 0? Why the first element, save it to min instead of starting with a number like 0 or like 2 billion. Okay, we said depending on what kind of numbers are in the array list that we're searching through, okay, that could make a difference. Like what if we're trying to find the minimum number, but we start with min equals 0. And everything in the array list are positive numbers. Then if we run this find minimum algorithm, then the result we're going to get at the end is 0, because every element in the array list, if it's positive, then it'll be greater than 0. Okay. All right. So yeah, and then we do have that loop going through, and then we just compare every time with the current element. That we compare the current element to what is currently saved in min variable, right? And then yeah, and then if we find anything that's smaller than what's saved in current in min variable, then we replace that with the current element. Okay. So the pattern is we start with the first and we compare the rest. Yeah, like maximum algorithm, same thing, right? Here I just added one more thing here, the index number, so that we can also return that index number when we run this algorithm. So again, we start with the first element, very important, right? And then we start comparing with the second element. The only differences are here is the comparison here is different. So before we're trying to find smaller number, but now we're trying to find a bigger number, so that has to be greater than. And here max value equals nums.getI, so we replace it if we find a bigger number. And then we also keep a track of the index. Okay. And then here, unlike before, we return the index of where that maximum number is. Okay. So yeah, I mean, find max. Sometimes we need to return the position. We need to know about the position. It's like index of method, yeah. Sum and average, these are very easy, right? I mean, we should know them by now. But like here, I used the for each loop. So for each int num in nums, we added to some variable, and then at the end we divide sum by nums.size. But again, always watch out for integer division. So we need to cast one of these to double type before actually carrying out the algorithm. All right, and a lot of the times on the exam they test you on like checking whether whatever is in the array list or array has a certain property, or is there anything that meets a certain criteria. So this is different from like searching, where we specifically try to search for an element, but here we're checking if one of the elements has some property. All right, so here has any negative. So we run a for each loop, and then if num is less than 0, we are going to return true, and if not, we're going to return false. But very important thing here, guys. Like a lot of the times students get confused where, I mean, should I have that return false statement inside the loop? Like what condition should we have inside the loop? Like return true, return false. So here let's think about it. We're checking if we have any negative number inside our array list. So if we find one negative value, then we can stop, right? So if we're not looking for how many negative values there are. If there's at least one negative value, we stop and we assume that, okay, so this array list doesn't have all positive values, right? So that's the key here, guys. The condition that will allow us to stop in the middle of the traversal will go inside the loop, okay? When we are ending a method with the return true, of course you can have variable assignments, then in that case, you kind of have more freedom, but it's inefficient. So here, we can stop if we find a negative value. So, and then we stop with return true. So imagine if we have return false in there. So if the condition would be if num is greater than 0, return false. So if the first number is positive, you return false and you end the method. But that's not how this algorithm should work, right? When are we returning false? When we search through everything, and if we didn't find a negative value, that's when we stop. But here, yeah, and so if the return false goes inside the for loop, okay, that's going to end prematurely, like after first positive number, it's going to end, right? Which would be wrong. So here, general pattern, return true as soon as we find one match, return false only after checking all. So think about when you're going to return, true, like after in the middle or after running through it all. Okay, so that will make a difference. All right, has all property, so all positive. So this would actually illustrate this a little better. So here again, we return true, has any negative. So if an array list had any negative values, we return true. But let's look at this one, all positive. It means that if we have one negative number, then it's not all positive, so we're going to return false. So now that return false goes inside the for loop under the if condition. Why? If num is less than or equal to 0, we're going to return false, meaning if we find a negative number, we don't have to search through the rest of the array list because it's false no matter what, because we just found one negative number, right? So we can stop in the middle of the traversal, we can end. Now what about return true here? When can we return true? After checking all of the elements, right? After checking all of the elements. That's why return true has to come on the outside of the for loop. Okay? So opposite logic from has any, we're returning false as soon as we find one failure. So now we have return false inside our if statement. And yeah, depending on what you're doing, that could also change, right? So again, like these algorithms, guys, I'm not showing this to you for you to memorize, okay? You need to understand how you can check these, how you can achieve these tasks, all right? All right, count property, so we're counting matches. So as you can see, if word dot equals target, we're going to increment the count. Here, we're just searching through the entire array list. Oh, by the way, did I mention it? Well, for each loop, you can also use with array list, okay? So if word dot equals target, we increment the count. I mean, we're not going to skip any elements in the middle or anything. If it equals, yeah, great. If not, we move on. So we don't need to do anything special here. All right, and the important thing though is here we're counting how many occurrences there are. So we're not going to return a value inside a if statement. Okay, we need to keep on incrementing our count variable throughout our traversal, and then when the loop ends, we're going to return the count. Okay. So pattern initialize counter, increment on match, and then return it when the traversal ends. All right, so consecutive pairs has consecutive duplicates method. So, I mean the methods, these are methods that I wrote. I mean they don't have, what I mean is they don't have has consecutive duplicates method in Java.